So, good morning all. Continuing with the unit number 6, that is templates. In today's session, I am going to start with the concept standard template library. In short, it is called as STL. Then important points about STL is algorithms. What are the different algorithms that we are going to see in today's session? Then containers, functions, iterators. These are the four components and very important components with respect to standard template library, and today's session we are going to cover it. If time permits, we will go for question and answer session. So let's begin with the standard template library. In short, it is called as STL. The standard template library is a set of C++ template classes to provide common programming data structures and functions such as list, stack, arrays, etc. You are familiar with these data structures? You have learned it already, what is meant by list or what is stack and what is arrays. So this STL is a set of C++ templates classes to provide a common programming data structure and functions to list, stack, array, view, etc. So what is this STL? STL is a library of container classes, algorithms and iterators. Keep in mind, this STL is a library of container classes, algorithms and iterators. It is a generalized library, and so its components are parameterized. A working knowledge of template classes is prerequisite for working with STL. So you should be familiar with the template classes, and we are already familiar with the template classes as well as template functions in the last two lectures. So to understand this STL, you should know the template classes. So let's see the important components of STL. STL has four components. First is algorithm. STL will consist the different algorithms. It also consists the containers. Containers will hold different data values. It also consists the functions. They are responsible for different operations to be carried out. Next is iterators. Iterators is component of STL which help us to iterate over the data structure. As we have different kinds of data structure, to iterate over this data structure or move backward or forward over the data structure, we require iterators. So keep in mind, these are the four important components of STL. First is algorithm, next is containers, functions and iterators. So let's begin with the algorithms. So the header algorithm defines a collection of functions especially designed to be used on ranges of elements. So these algorithms are nothing but the collection of functions especially designed to be used on range of different elements. They act on a containers and provide means for various operations for the content of the containers. So with the help of algorithms, we can do the various operations on the contents of containers. So what are the different algorithms? So you are familiar with the sorting, searching, important STL algorithms, useful array algorithms, and partition operations. So these are the different algorithms. If you want to play with the numeric, value array class algorithm is used. So this is about the algorithms. Next is containers. Containers or container classes are store objects and data. What is containers or container? It is a stored object and data. Containers can be described as the objects. Containers can be described as the objects that hold the data of the same type. Keep in mind, these containers will hold the data of the same type. So containers are used to implement different data structures. For example, arrays, list, trees, and so on. There are in total 7 standard first class container classes and 3 container adapter classes, and only 7 header files that provide access to these containers or container adapters. So let's see what are the different containers. So first container is sequence containers. It implement data structures which can be accessed in a sequential manner. First type of container is sequence containers, which will implement the data structures which can be accessed in sequential manner. For example, vector, list, DQ, array, and forward list, which is introduced in C++ 11 version. So these are the different sequence containers. As the name suggests, you store the values in sequence in these containers. In vectors, you can store the sequence values. In list, you can store the sequence values. In DQ, arrays, and forward list. In all these containers, you can store the sequence values. Let's see the different types of containers. There are actually 3 types of containers. So first, as we have just seen, is called as sequence container. First type of container is called as sequence container, and as the name suggests, it will store the sequence data structure. The data structure having the values in sequence. For example, vector, DQ, and list. So this is the first type of container, and by looking at this name of the container, you can understand what kind of container it is. So it is a sequence container which store the sequence values. Second is associative container, which will store the values of set, multi-set, map, and multi-map. So second type of container is associative container. Whereas third type of container is called as derived container. In this derived container, you can store, or it is derived from the sequence container or associative container. So for example, stack, queue, and priority. These are the examples of derived container. So keep in mind these are the three types of containers: sequence container, associative container, derived container, and these are the examples of respective container. So container adapters, it will provide a different interface for sequential containers. So queue, priority queue and stack. So these are the examples where you will have container adapters. Next is associative containers. It will implement stored data structures that can be quickly searched and with the complexity O log n. This is the complexity of this search. For example, set, multiset, map and multimap. Next is unordered associative containers. Unordered associative containers, which will implement unordered data structures that can be quickly searched. So, for example, unordered set, unordered multiset, unordered map, unordered multimap. So, these are the examples of unordered associative containers, and all this has been introduced in C++ 11 version. So let's see the flowchart of adaptive containers and unordered containers. Flowchart of adaptive containers and unordered containers. So here it is, all these are adaptive containers, whereas all these are unordered containers. So let's begin. For you, is order important, or whatever elements you will have, if you want to maintain the order in that elements? If it is yes, go for adaptive containers. If it is no, go for unordered containers. So let's begin with that is, we want our order is important in our data structure. Yes, we want order, so go to adaptive containers. If you want lasting first out order, yes, then go for stack. That you are a bit already familiar with. I am not going to explain stack coding. If you want to maintain this lasting first out order, if it is yes, go for stack. If it is no, again go to move forward. If you want order like first in first out, if it is yes, go for queue. If it is no, go for priority. And all these containers are nothing but the adaptive containers. And so all these containers will have order of the elements. If it is not, if order is not important to you, just ask yourself a question: do you want to allocate duplicates, allow duplicate values in your set? If it is yes, then go and just ask second question: map key to value. If map key to value, if it is yes, go for unordered multimap. If it is no, go for unordered multiset. If you don't want to allow duplicate values into the set, then go for here and again ask question: map key to value. If it is no, go to unordered set. If it is yes, go to unordered map. So all these containers belongs to unordered, and when to use a particular container, that you have to decide based on this question that we have just seen. If you don't want order, then go for all these things. If you want to maintain the order, go for this stack queue and priority queue. So moving forward, next is flowchart of sequence containers and ordered containers. Sequence containers and order containers. So here it is. You have to ask yourself if you want to a dynamic size. If you want a container of dynamic size, if it is no, go for array. You are already familiar with this array, wherein you can store the values which is already, size of the array is already defined. No dynamic memory is allocated for the array. If you want the dynamic sized array, sized values, just if it is yes, ask the question, keep the sorted. If you want to sort it, if yes, go for the main purpose. What is the main purpose? If the main purpose is search by keys, go to this flow. If it is not, or main purpose is in order traversal, go for this. If the main purpose is in order traversal, then go for vector, sorted or pat set. Go for the vector. Our main purpose is for search by keys. Again, if you want to allocate duplicates to no, if yes, then again ask the question, map keys to values. If it is yes, go for multi-map. If it is no, go for multi-set. If you want to don't allocate duplicate values, again ask question, if mapping key to values. If it is yes, go to map. If it is no, go to set. All these called as order containers. All these belongs to order containers. If you don't want that sorting things, then just go over here, insert or erase the element in the middle. If you want to perform this operation, if yes, go for frequent traversal. If you don't want frequent traversal, then go to list. If it is yes, go for again size varies widely. If it is yes, go to DQ. If it is no, go to vector. And again, if you don't want to perform this operation, insert or erase elements in the middle, next question is insert erase elements at the front. If it is yes, go to persistent positions. If it is yes, go to list. If it is no, again the same question, size varies widely. If you want to do this, go for DQ. If you don't want to do this, go for vector. So this is the sequence of containers, sequence containers and order containers. So this is the order container, all these things, and these are nothing but the sequence containers. So as per the requirement of the data structure, you have to choose the particular container. So next is functions. STL includes classes that overload the function call operator. So this STL, standard template library, has the function call. So what is this? It is an instance of such classes are called as function object or constructor. It is the instance of these classes are called as function objects. Functors allow the working of associated functions to be customized with the help of parameters to be passed. So built-in functions are functors. Next is iterators. As the name suggests, iterators are used for working upon a sequence of values. They are the major features that allow generality in STL. So iterators are present in the STL, which will help us to iterate over the data.